In 2050, a common infection could kill you, not because medicine stopped working, but because economics did. Antibiotic resistance is one of the biggest threats to global health. By 2050, it could cause 10 million deaths per year, more than cancer kills today. But here's the paradox. Even though we desperately need new antibiotics, pharmaceutical companies keep abandoning them. Why would the market fail so catastrophically? First, the biology. Bacteria evolve through natural selection, and they do it fast. When you take antibiotics, you're creating intense evolutionary pressure. Most bacteria die, but a few random mutants survive because they happen to have genes that resist the drug. Those survivors multiply, passing resistance to their offspring. Within days, you've gone from a treatable infection to a resistant strain. Now here's the kicker. Bacteria can share resistance genes horizontally, not just parent to child, but bacterium to bacterium, even across species. It's like if you could catch immunity to peanuts from your neighbor. This means resistance spreads exponentially. One resistant bacterium in a hospital can transfer its superpowers to dozens of other species within weeks. Now the economics. Developing a new drug costs about $1 to $2 billion and takes 10 to 15 years. Normally, pharmaceutical companies recoup this through sales. A cholesterol drug? Patients take it daily for decades. That's steady revenue. But antibiotics are the opposite. Doctors prescribe them for days or weeks. Then you stop. Even worse, new antibiotics are held in reserve. They're only used when older, cheaper drugs fail. This is clinically smart. It slows down resistance. But economically, it's a disaster. Here's the problem in economic terms. Antibiotics create what's called a negative externality. When you use an antibiotic, you get healthier. That's your private benefit. But you also accelerate bacterial resistance for everyone else. That's the social cost. Markets are terrible at pricing externalities. Here's the formula driving the problem. Social cost equals private cost plus externality. Translation? You pay $5 for amoxicillin. Society pays billions in resistance. The math doesn't add up. Let's visualize this. In a normal market, supply meets demand at an equilibrium price. Everyone who values the product more than it costs to make gets one. Efficient. But with antibiotics, overuse creates dead weight loss. That's economists speak for value that's destroyed when markets misallocate resources. There's a gap between social cost and private cost. We consume too many antibiotics because individuals don't pay for the resistance they create. And pharmaceutical companies? They see a product that's used sparingly, goes generic quickly, and faces price controls. The return on investment is abysmal. So here's where biology and economics collide. Every time someone takes an antibiotic, they're making an individually rational choice. Get better now. But collectively, we're depleting a common resource, antibiotic effectiveness. This is a textbook tragedy of the commons. If you're not familiar, it's a concept from 1968 proposed by ecologist Garrett Hardin. Imagine farmers sharing a pasture. Each farmer adds more sheep, chasing personal profit, but the grass gets overgrazed and dies. No one wanted to destroy it, but individual incentives led them there anyway. That's us with antibiotics. In biology, we call it evolutionary pressure. In economics, we call it externality-driven market failure. But it's the same phenomenon. The faster bacteria evolve resistance, the faster antibiotics lose value. And because companies can't capture the social value of preserving effectiveness, they underinvest in new development. Between 2003 and 2013, more than 15 major pharmaceutical companies exited antibiotic research. Novartis, AstraZeneca, Sanofi, all gone. Since 1984, the FDA has approved only 2 new classes of antibiotics. 2 in 4 decades. Meanwhile, the World Health Organization lists 12 bacteria families as critical threats. We're running out of options, and the market won't fix this on its own because the market is responding rationally to irrational incentives. The consequences are already here. In 2019, nearly 5 million deaths were associated with antibiotic resistance. That's more than HIV and malaria combined. In the United States alone, resistant infections cost the healthcare system $4.6 billion per year, and it's accelerating. Carbapenem-resistant Enterobacteriaceae, CRE, nicknamed nightmare bacteria, now kills up to 50% of infected patients. We're seeing infections that are literally untreatable. Doctors are resorting to antibiotics from the 1950s. Drugs we stopped using because of terrible side effects. This isn't some distant future scenario. It's happening now, in ICUs, across the world. So what's the solution? It requires rethinking how we value antibiotics. Some economists propose market entry rewards, guaranteed payments of $1 to $3 billion for any company that develops an effective new antibiotic, regardless of sales. This decouples revenue from volume. Others suggest treating antibiotics like public goods, funded through government R&D or international coalitions. The UK has already piloted a subscription model, paying companies a fixed annual fee for access to antibiotics, not per pill sold. These aren't perfect solutions, but they recognize a fundamental truth. Markets are tools, not laws of nature. When markets fail, we redesign them. We've done it for vaccines, for rare disease drugs, for climate technology. Antibiotics are no different. The biology won't change. Bacteria will keep evolving, but the economics can. Antibiotic resistance is a crisis born from 2 forces, evolution and economics. The bacteria are just doing what bacteria do. The market is just doing what markets do. The question is, what will we do? Because the answer isn't better biology, it's better policy.